Okay, so we are in section 6.5, and we're going to talk about logarithmic properties. In this section, we're going to focus on the product rule for logarithms, quotient rule for logarithms, power rule for logarithms, and we're going to use those rules to expand logarithm expressions and condense logarithmic expressions, and we're also going to learn a formula called the change of base formula for logarithms. So the first rule we're going to talk about is the product rule, and the product rule says that we can write a product, a logarithm of a product by rewriting it as the sum of the individual logarithms. So log base b of m times n is the same as log base b of m plus log base b of n, and remember b is always greater than 0. So how to, given the logarithm of a product, use the product rule of logarithms to write an equivalent sum of logarithms. This is very, very important, okay? You want to make sure that you factor the argument completely. Expressing each whole number as a product of primes. Okay, so don't forget to do that. And then you're going to write the equivalent expression by summing the logarithms of each factor. So let's expand log base 3, 24x times 2x minus 5. So first we need to rewrite this as a product of primes. So 24, each whole number is a product of primes. 24 is, we'll go over here and do this. 24 is 2 times 12. 2 is a prime number. 12 can factor into 2 times 6. 2 is a prime number. 6 can factor into 2 times 3. Both of those are prime numbers. So 24 is 2 times 2 times 2 times 3 times x times 2x minus 5. Okay. So we can write this as the product or as the sum of the individuals. So this is log base 3 of 2 plus log base 3 of 2 plus log base 3 of 2 plus log base 3 of 3 plus log base 3 of x. And let me erase this here. So that's 2, 2, 2, 3, x, and then we have one more, plus log base 3 of 2x minus 5. Now, you can look at log base 3 of 2. There's 3 of them, so we can rewrite that as 3 times log base 3 of 2. And then just go ahead and add the rest, plus log base 3 of 3, plus log base 3 of x, plus log base 3 of 2x minus 5. And that is our final answer. Okay. Now let's expand log base b of 8k. Actually, you guys try this. Pause the video, come back, and we'll go over it. So log base b of 8k. 8 can be written as 2 times 2 times 2 times k. So this would be log base 5 of 2 plus log base 5 of 2 plus log base 5 of 2 plus log base 5 of k. And there are 3 log base 5s of 2, so I can rewrite that as 3 times log base 5 of 2 plus log base 5 of k. Alright, so now moving on to the quotient rule for logarithms, and it says we can break a quotient into a difference. So we would subtract log base b of m minus log base b of n. So for this one, you want to first make sure you express the argument in lowest terms. So you're going to factor the numerator and cancel out any, and denominator and cancel out any common terms. Then you're going to write the expression by subtracting the logarithm of the denominator from the logarithm of the numerator, and check to see that each term is fully expanded. If not, apply the product rule for logs to expand completely. So let's look at this first one. All right, first we're going to see if we can factor anything out and cancel, and we can't. So next, we're going to rewrite it as the difference of this is log base 10 of 5x minus log base 10 of the denominator, which is 4x plus 3 times 1 minus x. But we can do this first one. This is a product of 5 times x. So this would be log base 10 of 5 plus log base 10 of x. And we are subtracting, this is product rule too, right? So we can expand that one into log base 10 of 4x plus 3 plus log base 10 of 1 minus x. All right, so now I can take the parentheses away and just say, okay, I'm doing log base 10 of 5 plus log base 10 of x minus log base 10 of 4x plus 3. And we're distributing this minus sign right here to each of these terms. So that means it's going to be minus log of 1 minus x. All right. All right, so let's try this one together. I know it's a try it, and I normally let you do this one on your own, but let's go ahead and do this one together. So for this one, this would be one where you could actually factor out part of the numerator, so that would be 7 x can factor out of the 7x squared plus 21x, and that would leave x plus 3, right? And then that's over 7x times x minus 1, x minus 2. And then hopefully you'll see that the 7x's cancel. So that leaves log base 3 of x plus 3 over x minus 1, x minus 2. So this is a quotient, so we're going to write it as the difference of log base 3, the numerator, and the difference of that and the denominator. So log base 3 of the denominator, which is x minus 1 times x minus 2. Well, we're good with this first part. But this second part we can write as a product. Log base 3 of x plus 1 plus log base 3 of x plus 2, expanding it into a sum. And so that means we would distribute that minus sign to each of those pieces. Would leave log base 3 of x minus 1 minus log base 3 of x minus 2. I was missing a parenthesis there. All right, so that brings us to the power rule. And the power rule says that if you have a power, such as a log of a power, log base b of m to the n, you can rewrite that as the exponent times the log of the base. Right? So to express that, you express the argument as a power if needed, and then write the equivalent expression by multiplying the exponent times the log of the base. So what we're doing here is, let's say you had like log base b of a to the c. You're going to rewrite that as c times log base b of a. So you're going to take this here and move it to the front. That's what we're doing. So let's expand this first one, log base 5 of x squared. So what we're going to do is we're going to take this 2 and we're going to move it to the front. Oops. And it becomes 2 log base 5 of x. So we just move that 2 to the front. So same thing here. Expand ln x squared. So natural log of x squared. We're going to take this 2, move it to the front. It becomes 2 natural log of x. And we're done. All right, so let's try this next one. I'm going to go ahead and do this one with you as well. This is really ln of x to the negative 2. Negative 2, because 1 over x squared, if we move that x squared to the top, it becomes x to the negative 2. So then we would rewrite this as negative 2 ln x. All right. This next one, we're going to take this 2 and move it to the front. And we're going to get 2 log base 3 of you know what? I realized that I just did here is that here was the problem, and earlier I was working through each of them just to make sure I knew what was coming, and I forgot to erase that part. Oops. So we were starting off with the answer, and I'm going backwards. So this one says rewrite 2 log 3 of 4 using the power rule for logs to a single logarithm with a coefficient of 1. So in this case, we're going backwards. We're going to move that to the exponent. So that's log base 3 of 4 squared, which is log base 3 of 16. Sorry about that. So if you look into your notes, I think I left that on the notes as well. Oops. All right. So here we're expanding the log. So why don't you try these and then unpause the video when you're ready to check your answer. Okay, so when we're combining all the properties together, you kind of have to do it in pieces. So for this first one, you've got the product and the quotient rule. So I've got log base 10 of x squared plus log base 10 of y to the third minus log base 10 of z to the fourth. And then I can take each one of these exponents and move it to the front. So it'll be 2 log x plus 3 log y minus 4 log z. All right, let's look at this next one. This is ln. The cube root of x squared is really x to the 2/3. And then we could take this and we would write it as 2/3. Oops, yeah, ln of x. So we're just moving that power to the front. So you had to rewrite it as an exponential form first. So get it out of that radical form, write it as an exponential form, and then move that exponent to the front. So let's look at this next one. We've got log base 4 of 27x to the third times 3x plus 1 over 3x minus 4. So this one, for this one, what you need to do is you need to write any whole numbers. Think about 27. Remember we prime factor it. Well, 27 is 3 times 3 times 3. Instead of writing that, and you could do this on the earlier ones we did as well, now that you know the power rule, 27 is really 3 to the third. So I'm just going to rewrite that first, like that. All right, so now I can write this as log base 4 of 3 to the third times x to the third times 3x plus 1 minus log base 4 of 3x plus 4. Alright, and then we'll come down here. And we have, so we have this piece here, which is product, so we're going to add. So we have log base 4 of 3 to the third plus log base 4 of x to the third plus log base 4 of 3x plus 1 minus log base 4 of 3x plus 4. And now we can take each of these exponents and move those to the front. So we have 3 log base 4 of 3 plus log, 3, because we're moving these to the front. So 3 log base 4 of x plus log base 4 of 3x plus 1 minus log base 4 of 3x plus 4. So that one expands to a pretty long one. Okay, so we're going to stop right here and we're going to pick back up with part 2.